So today's topic title is short circuit capacity and per unit deviation. In this short lesson, I will derive the short circuit capacity, connected it to a per unit and it will with the powerful short circuit, that is 1 by x per unit. Let us go step by step. So short circuit capacity is also called as the short circuit MVA. So short circuit capacity or the short circuit MVA, the word only itself shows that it is the apparent three phase power. It is the apparent three phase power that would flow into a that would flow into a voltage three phase fault at a bus. So this was the simple definition of the short circuit capacity. So here we have seen on the large screen that we have written here AC short circuit capacity. For the AC, root under 3 short circuit capacity in MVA formula we have root under 3 VLIAC into 10 power minus 3 MVA. Here VL is the line to line RMS voltage at the faulted bus and ISC is the RMS three phase fault current in ampere, and the factor 10 power minus 3, the factor 10 minus 3 converts the kVA to the MVA. So if you use kV, kilovolt and kiloampere, you don't need here one point here that if you need, if you use kilovolt and kiloampere, then you don't need 10 power minus 3. So to compare the different voltage levels, we switch to the per unit. For a three fault system remains balanced, so we use only the positive sequence Thevenin network. In per unit, the fault current is simply the pre-fault bus voltage in per unit divided by the Thevenin's reactance in the per unit. So what I have told here, whatever it is written that ISC per unit is equal to VF of per unit divided by the X of per unit, means if you want to compare the different voltage level, we have to switch to the per unit. For a three phase fault, the system remains balanced, so we only use the positive sequence. Positive sequence network Thevenin network. Positive sequence uh, Thevenin, Thevenin network. Positive sequence Thevenin network. In per unit, the fault current is simply the pre-fault bus voltage and divided by the Thevenin reactance in the per unit. So here, so what is VF and the X per unit? That is the X VF per unit is the pre-fault bus voltage. It is often taken as the 1.0 per unit. And the X per unit, that is the Thevenin reactance to the fault, that is the positive sequence network. So this was the simple derivation, simple definition of all the things. Next that we have here, that is on screen we have shown here, that is base voltage. Base voltage, base current, base current for the conversion to the actual amperes. So pick the system basis, that the base MVA SV, base MVM SV, and the line to line voltage VB. The corresponding base current IV is equal to the base corresponding I2. What I told here, that base voltage SV and the base line to line voltage VB, the corresponding IV can be written as SV by root under 3 of VB in ampere. If you want to write in the kilo ampere, then it will be in ampere, and if you want to write in the kilo ampere, we have to remove 10 power 3. So if you want to write in the kilo ampere, simply we have to write IB is equal to SB by root under 3 of the VB. If you want to write in the kilo ampere, we have to remove this part, 10 power 3. So convert the PU current to the actual current. So ISC will be is equal to ISC per unit into IV. So already we have the value of the IV, that already we got here, VF of per unit by X into per unit into IV is equal to SB into 10 power 3 root under 3 into VB. We can remove this part also. Already I have discussed why. So to get the actual amperes, multiply the per unit current by the base current. Substituting IB gives the compact expression. It will give the compact expression. Next one, that we have the short circuit MVA in terms of the basis and the X. So we have to start from the SC, that is the SC is equal to SCC is equal to root under 3 of VL into IC. Set IVL is equal to VB. We have to set here VL is equal to VB, that is the rated bus voltage, that is the rated bus voltage, and we have to substitute ISC. So if we are simplifying, the simpler simplification that we have here is that VL is equal to, so root under 3 VL into IV, VF per unit, that is we have written here. So if we'll solve this part, we'll get here VF per unit into SB divided by X of per unit in MVA. So using the VL is equal to VB, at the faulted bus and substituting the current from the per unit, the short circuit MVA becomes short circuit MVA becomes VF per unit into SB divided by the X into per unit. So common assumptions VF, so we have commonly, if VF per unit is equal to 1, then simply the SCC will be equal to SB by X of per unit in the MVA. So in planning a study, we usually take the pre-fault bus voltage at the 1.0 per unit, then go to the design formula, that is the SCC will be equal to the SB by X of per unit. So final step is the SCC is equal to SCC in per unit is equal to SCC by SB is equal to VF by per unit divided by X of per unit. So it will be equal to the 1 by X of per unit. So what I have told here, so we can write here SCC into per unit is equal to SCC by SV here. So we can write here VF, already we have got this formula here, so we can write here x of per unit. So same thing we can write here, that 1 by x into of the per unit. So this is the final formula that we want. So normally by the base MVA and you get the clean short circuit in per unit, so fault is essentially the inverse. So here what we got here, fault level is essentially essentially the inverse of the per unit reactance. So this is the final formula that we got here. If uh, if you want to quick numeric check, then we suppose we have given SB is equal to 100 MVA, VB is equal to 132 kilovolt, X is equal to 0.20 per unit, and VF is equal to 1.0 per unit. So SCC we can write here, that is the SCC we can write here SB, that is the 100 divided by the X, that is a 0.20. So if you solve this one, so this one 0 0, it will become the 500 MVA. Similarly we have the ISC is equal to SCC root under 3 into VV. So SCC how much we have here, 500. So 500 divided by 1.732, 1 root under value 1.732 into VV. What is the VV? We have 132. So if we will solve this one, we will get here like 2.19 kilo ampere. So IB will be equal to SB, that is the 100 divided by that is again we have the 1.732, that is the root under 3 value into 132 into VV. So we'll get here round figure 0.438 kilo ampere. So ISC in the per unit will be equal to the ISC value, that is the 219 divided by IB 0.438. It will be equal to round figure 5, that it can be equal to also equal to 1.0.20. So example with the 100 MVA 132 kV base and the X is equal to 0.2 per unit, the fault level is the 500 MVA. Fault level is the 500 MVA and the actual current is the 2.19 kilo ampere. So dividing by the base 0.438, dividing by the base 0.438 gives the 5 per unit, exactly 1 by x, exactly 1 by x. So common pitfalls, one line reminder that I have discussed here, that keep the units constant, kilovolt to the kilovolt to ampere needs 10 power minus 3, but kilovolt to kilo ampere it doesn't require. Next, use positive sequence network. Use the first, second, third one. Use the positive sequence network for a 3-phase fault. Then we have to check here VF is equal to 1.0 per unit assumptions. 1 per unit assumptions is common, but verify if the bus normally runs low or high. So next one we can write here, Next assumptions, when the system configuration changes, when the system configuration changes, recompute the x. When the system configuration will get, we have to recompute x in the per unit only. The fault level will change. Fault level will change. Mind the units, comma sequence network, the 1.0 per unit voltage assumptions, and remember that adding source in parallel lowers x and raises the fault level. What I told you, always we have to remember, when we are adding the sources in parallel lowers to the x, raises the fault levels. So here what we have to remember, SCC is equal to root under 3VL of ISC. SCC in the per unit, we have to remember 1 by x in the per unit. So that's the derivation. You will get again and again real time SCC from the volts and amperes. The shortcut is 1 by x. So like, subscribe. Next symmetrical fault examples, breaker sizing. If this helped, like the video, subscribe. In the next video, we'll size a breaker from the one line diagram using the exact method. Thank you.